Hey, here is a video to go through the 30, 60, 90 triangle. I hope that when you watch it, you can speed me up. Speed back the playback time. So if it's a 30, 60, 90, the first thing we're going to do is we're going to start with this equilateral triangle. All the sides are equal. That means all the angles are equal. And if you remember, one of the most important things about geometry is that triangle angle sum theorem says the sum of the angles of a triangle add up to 180 degrees. So if there's three angles, they are all the same. We can divide 180 by 3 and figure out that all of these angles are 60. Okay, so now what we're going to do is we're going to drop a perpendicular from this 60-degree angle. And I'm going to try to convince you that it bisected that angle. So I'm going to try to convince you that this is 30 and this is 30. Okay, so if this angle here is 90, then this angle here is 90. And this side is reflexive. That means that this side from here to here, this side right here, is equal to itself. So by the reflexive property, that side's equal to itself. And then I'm going to use this 30-degree, this 60 and this 60. So I'm going to compare this angle and this angle and this side. So I'm going to tell you that these two triangles are congruent by angle, angle, side. The side that I'm using is not in between these two angles. That's why it's not angle, side, angle. The side that's in between these two angles is this side, and I don't know anything about it. So, if this triangle on the left is congruent to this triangle on the right, then all the corresponding parts are equal. So that means that this side down here corresponds to this side down here, and those pieces are equal. And then if this is 90 and this angle is 60, 90 plus 60 is 150. 180 minus 150 is 30. Therefore, this angle is also 30 because of CPCTC. The corresponding parts of congruent triangles are congruent. So now we have a little 30, 60, 90 triangle. And if each side is 1 of length 1, then this side, this bottom, this base that it's sitting on, when I bisected that 60-degree angle, I also bisected this side of length 1, and I made both of these portions a half. By the Pythagorean theorem, I can figure out the length of this side. So I can do a squared plus b squared equals c squared. Four fourths minus 1/4 is 3/4. Take the square root of both sides. That's the same thing as taking the square root of the numerator and the square root of the denominator. So that's the square root of 3 over 2. That's why when we talk about the 30, 60, 90, we've got the 1/2, the square root of 3 over 2, and the 1. So if you want the sine of 30 degrees, it is O over H, a half over 1, which is just a half. And the cosine of 30 degrees is A over H, square root of 3 over 2 over 1, or just square root of 3 over 2. And your ordered pair for 30 degrees, if you looked it up on your circle chart, is cosine, comma, sine. This will seem vaguely familiar to you, possibly. These aren't the values I put on the board for you all in geometry. In geometry, we started out not with a side of 1. We started out with a side of 2. And so we said the side opposite the 30 was 1, and the side opposite the 60 was square root of 3. And we probably did an S or an X for those. So we had the S, the 2S, and the S square root of 3. But these are ratios. They're trig ratios. So if the hypotenuse is 2, then the side opposite the 30 is half of that. If the hypotenuse is 1, then the side opposite the 30 is half of that. It's just how the trig ratios work for this 30, 60, 90.